So now demonstrate the simulation with obstacles. First, I'll just see if there's any process running. Okay. So I've added some obstacles. Okay, so let's say we set washroom, supply room, ward 5, reception, office 1. Starts with the washroom, which is the farthest. You can see the cost maps have are more concentrated because of the obstacles. You can also see can visualize the LiDAR on gazebo. Also, one thing to point out is the LiDAR, because of their height, it will not be able to detect these stands. Even these stands are way lower than even how much we lower the LiDAR. I don't think it's going to detect this unless we use even proximity sensors which are quite below, like same level as this, or the LiDAR should be powerful enough to maybe 3D LiDAR so that it can detect these metals. So initially when I set the locations for these goals, I had put it inside, like the robot can go and enter inside, but then when the robot went inside, it would just maybe go straight, then get stuck here, and then the navigation would be failed. But that's because it cannot detect this. So our first goal is the washroom, then it goes to supply room, then ward 5 reception, office, then it will automatically get back to the charging station. So the first goal, I think, has been achieved almost. Here there are some parameters we can also make use of, because it calculates the distance remaining to the current goal, and it also calculates the time. So I think I will include these and also be able to show them on the graphical user interface, and perhaps we can compare this with the distance a nurse would take, like in a realistic scenario, with this kind of distance, how a human would take to deliver this medicine. So now it has calculated the distance to the other goal and then the time it takes. So the next goal is supply room. You can see the first goal has reached successfully, which is washroom. They're now going to the second goal, which is the supply room. Reached successfully. So then the planner server listens to the next goal in the waypoint, calculates the trajectory. So it should be around here, ward 5. Oops, got stuck. So this is one of the problems which so it wasn't able to see this obstacle, and now it got stuck. So by default there is a behavior server in ROS 2. So when stuff like this happens, it aborts that goal and it tries to calculate another goal. So it's here, it says that aborting handle. Let's see what. So the goal was aborted. So that's the behavior server. Even though we can set other custom commands when such happens, and we have to now modify more custom behavior trees for our if we want a custom action, but it will usually do this abort, then maybe try to reverse and then call the goal again, like what it's doing now. So it took a reverse, then changed, then it's still going to pursue that goal which it had targeted before. Board 5. Let's see. So you can see here it aborted this because there was a tolerance of 0.5 thing because it was going against the obstacle, but the odometry wasn't moving, the IMU. So it aborted that, then it calculated the goal again. So that's one advantage of using behavior trees in navigation 2 as compared to nav 1, which they used state machines. So there was less of prioritization. So we can see that it does detect so I was able to avoid that obstacle. So the goal to word 5 was aborted, and it took the following goal, which is to the reception. So this goal has been skipped, then it goes to the reception. So it was successful at the delivering at the uh, navigating towards the reception. Then it heads to office 1. So office 1 is successful. Then it's after finishing the whole waypoint, it's going to go back to the charging dock. So you can see that the goal has reached successfully at the charging dock. So that is the demonstration for the obstacles. I'm still working on trying to block some roads. Like say here I block this path, but then I'm still looking into, because when I tried here, the robot would come but it would not detect this obstacle. It would just overrun it. So I'm not sure if maybe the way this obstacles was made, or it's because of the height of this of the base, because that's the one problem we have right now. It's the height. It cannot detect the very lower obstacles, but that's because we're using one LiDAR, which is up here, so the only workaround for that is to try as much as possible to make the robot not go into places whereby it's enclosed with these lower bases. So like initially the coordinates were very inside, like say here. So when the robot comes here and tries to turn, it would go and hit this. But now I've just made it to come here. Maybe these locations are not yet a bit inside, so that's why when it came here, it tried to turn, it could not see this though, so it get blocked. So that's one downside for this. And the other downside, it's the speed of the robot. It's slow, and that's because we're only using one LiDAR. Some people use two LiDARs, especially for the AGVs in the industry. Their precision is much higher, so they use one LiDAR here and the other one on the back, so that they can achieve 360 degrees here and here. So one LiDAR is responsible only for one side, so that's why it's much faster. And they also use cameras as well, so they use visual SLAM and they sensor fuse it with the two LiDARs. So that's one downside, which I think it has to be considered, especially if it's in a hospital environment. The speed here is very critical, and the time for delivery. So yeah, and also it's simulation, so we are not very accurate, especially like because many things have to come into play, like the wheel diameter of the robot. This might not be very real compared to the real physical robot. So, and also these obstacles, there could be many, it's not 100% accurate, so that's another downside as well. So I will end the the video here.